One of the main things we're going to be studying in this unit is matrices. So what is a matrix? We're going to find out. We're going to do mathematics with matrices. We're going to see applications on where to use them. But first of all, just what a matrix is a rectangle with a bunch of numbers inside of it. So for example, 2, 3, 5, 1, 4, -2. That would be a matrix that we would say has 2 rows and 3 columns. The rows go this way, and columns go up and down, just like columns on a building go up and down. So that's one way to remember. And you would know that this one has 2 rows and 3 columns. And we're going to use how many rows and how many columns to describe the matrix. Okay? We're going to be able to do some math. We're going to find out that these matrices are used to organize data. And what this one that I just wrote, one of the things this matrix that I just wrote could be organizing and could be representing is it could show 2x plus 3y equals 5 and 1x plus 4y equals -2. So it could show a system of equations, what we did last class and tried to solve. You could put it into a matrix. And so you can see where the mathematicians like this, they can write less things. They didn't have to write the x's, they didn't have to write the y's. It's a little bit more, no equal sign. It's a little bit more streamlined and a little bit more efficient. With a matrix then, you would have to know that your first column represented your x values, your second column represented your y values, and your last column represented your answers. Okay? The horizontal entries are your rows, vertical entries are your columns. And we describe the size of a matrix by its dimensions, and dimensions are always the number of rows by the number of columns. So this is how I remember it. So what I use to remember this is the little saying, matrices rock. They're awesome. And if you remember that matrices rock, the RO stands for rows, and the CK stands for columns. It's perfect. Just a little stutter in there and you've got it. And you will be able to say the dimensions of a matrix from that. So if I have this matrix here, it has 3 rows and 4 columns, so we would say the dimensions of this matrix are 3 by 4. Matrices rock. And that'll be easier for you to remember, and it's important for a lot of the mathematics that we do with matrices. So the word that we sometimes use for the dimensions is order. It also means size, and then we state our dimensions for that. And it doesn't mean we multiply m times n, we just leave it as 3 times 2 or 5 times 1 or however much we have. So, question like this, state the order. We would look at this one. It has 3 rows and 1 column, so we would say this order is a 3 by 1. Here we have 4 rows, 3 columns, 4 by 3. And finally, 1 row and 4 columns. This would be a 1 by 4. Some other characteristics of matrices. We use capital letters to name matrices, and then we use little letters to talk about the elements or the separate numbers inside of the matrix. So the separate numbers inside of the matrix are called elements. Can be labeled with the whole matrix labeled with a capital letter, and then little letters to represent what's inside. Okay? So, for example, here's a matrix A, and you will notice in some textbooks they'll put a comma in between to, like, A11 means that it's in row 1, column 1. That's its position. If I look at this one, it's in row 2, column 3, so we label it as A23. In some textbooks, if you're dealing with smaller matrices, it's okay to omit the comma. Like A33 would just mean third row, third column. But as soon as you get it to be too big of a matrix, that you have like 10 or more rows and 10 or more columns, then you have to start using a comma, because if you go 10-2 or 11-2, you don't know if it's 11-2 or 1-12. So the comma would help there. So if this is the matrix M, and we wanted to find M13, we would go to row 1, third column, and it would equal 0. I'll give you a head start on the next two and the order of it. Did you get E for M34? And of course I chose all the fancy ones for the answer. 2, 4 would be pi. And the order, there are 3 rows, 4 columns. Matrices rock. Continuing on with some more definitions. We have special matrices. One of them is called a column matrix. It has 1 column. A row matrix. It has 1 row. A square matrix. If you have the same number of rows and columns, your numbers make a square. And so we call this a square matrix. Sounds like they just decided to make up definitions of what made sense. I mean, it's nice that at least the definitions make sense. I would hate that it would be like, oh, we're going to call, if it's in a square, we're going to call that a rabbit matrix. And if it has 1 column, we're going to call it a zebra matrix. And if it has 1 row, we'll call it a hippopotamus. And then you would have to remember all these animals and what they meant. That would be not very good definitions. But these definitions are really simple. We could probably have a test tomorrow and you'd get them all right, unless you mixed up your rows and columns. You'd like to do that? Boost up your mark? Okay, check out this. A 0 matrix is a matrix that has only zeros. But we don't talk about 2 matrices or a 4 matrix or a 5 matrix. It's just the 0 matrix, because 0 is important. This is the first one that's a little bit different. Identity matrix. Now, when you're talking about an identity matrix here, it's connected to the number 1. Okay? Now, with matrices, this is the special number 1. It has 1s along the diagonal and 0s everywhere else. And it has to be a square matrix. Now, we don't know where this comes into effect, but later on, we're going to need this matrix for a number of things. The identity matrix is going to be important for multiplying. You know with numbers, do you know your 1 times table? Yeah? How high? Up to 12? Do you know your 1 times table past 12? 1 times 72. Oh, you are amazing. So someone has definitely worked a lot on their 1s times table because they know it all the way up to 72. Well, this will be like that when we learn how to multiply. When you multiply by an identity matrix, it's like multiplying by 1. It doesn't change anything. But we're going to figure out how that works later on. Ooh. Okay, go. Oh. Yes. Oh, yes. Oh. And they're mostly straight lines. See how the hint was now? I didn't say you couldn't do that. Okay. Back to some matrices definitions. Transpose of a matrix. A transpose of a matrix is when you just change the rows and the columns. So if I have this matrix A that has 4 rows and 2 columns, I can draw the transpose, A with a T, by taking column 1 and making it row 1, and taking column 2 and making it row 2. And GT, same thing, column 1, and B shows that I almost know my alphabet, just not quite in the right order.